All right, hello, my name is Jacob Spilker, and this is my presentation on the first Physics 2211 lab of the semester, Constant Velocity. And I would like to apologize in advance if the audio and video quality of this presentation is a little bit shaky. I tried everything that I could to just screen record and capture the audio all from the same device, but for whatever reason, the software that I typically use to capture audio and screen at the same time was not working when I was exporting my video presentation. So the next best thing that I could work out to capture the audio was to record with a separate device. So that's what I'm doing. But anyway, let's move on. The introduction to this lab, the background. So what we're really doing is we are comparing the position of a moving object. In this case, we used a roll of tape from a computational and physical experiment, a computational model and a physical experiment, and we're going to track the motion of this object using these two different models and see how they compare. So for a computational model, we're using the GlowScript software, the coding software, and then for the experimental model, of course, we actually conducted the physical experiment, but we used the Tracker app to actually track the position and list out the position updates of our roll of tape as it was moving along the ground in reference to a meter stick. So some of the fundamental physics principles that need to be understood to understand this, this lab is mostly just the momentum principle or Newton's second law. And from here, you can derive the position update and further derive the velocity update formula. And these are very, very important for what we're doing in terms of tracking a moving object. And this is used, from what I can tell, very often throughout the physics world. And so that is the fundamental principle that we're leaning off of for today's lab. Now, here's just an overview. I've sort of already explained this. Using the GlowScript software, we're going to code a theoretical output of this graph at the roll of tape at ideal conditions. And then we're of course going to conduct the actual experiment and track that using software from Tracker, and then overlay the data to analyze the differences. So let's get into it. This is our experimental data. As you can see, my group and I have a roll of tape in reference to a meter stick. It's actually moving in the negative x direction, so we have a graph with a negative slope up here. But we can observe that the graph of the motion is relatively linear. I'll play this one more time for you guys. And as the object is moving, each one of these little red dots is an update in the position. And it actually updates in real time over this graph too, and in this list down at the bottom. So what we can do is we can take this list and we can copy and paste it into an Excel document to give us a nicer graph that we can then use to overlay the other computational model later. And taking the data from that table that I just showed you, we've calculated the initial velocity to be this vector right here. And so now that we have this data from our experimental model, we're going to move over to our computational model. And just a few things about the code of this data before we hop into the results. We took these numbers that we have here from our experimental data, and we applied it in our tracking software. So it's in our code right here, actually. And then we have the velocity and position update formulas as well. Oh, and also there's a net force of 0 because this is supposed to be ideal conditions. So that's what we're working off of. That's the background for the code. And it's going to give us this red line here. And because this data was negative, it actually took quite a lot of work to be able to manipulate the computational data and then transcribe it into a different software so that I could overlay it onto this graph that was inverted. But this is how it compares. And so you can see we have some deviations there. And I wanted to take a moment to speak about why those deviations could be present. First of all, some slight inaccuracies with Tracker. Obviously, we could have maybe not rolled the tape in a perfectly straight line, or maybe Tracker was a few frames behind, or the software stopped tracking before the motion actually ended at the end of the 1 meter, or maybe it started tracking slightly late. But that could be a reason for that deviation that we had there. And of course, there are also other forces present that, in the real world, in our actual experiment, we had friction and air resistance. So there's going to be some slight deviations, just if for no other reason other than the presence of friction. And lastly, rounding could be an issue because I did not round as far as I did on computational model that can, you know, not worry about the numbers. But that is all that I have for you. Thank you for watching, and have a great day.